Hello, makers everywhere, engineers, people who like to build things with their hands. I'm Carrie Sundra of Alpenglow Industries, and today Lee is joining me, and we're gonna try to troubleshoot their cool vintage Nixie tube multimeter kit. Or actually, it's not a kit, right? It was just
it's not a kit. It's just another thing.
Cool. And let's see. Before we get started on that, I was just going to go over like a few cool things that we've like finished up and have been doing and stuff like that. So the first is that you might see here the blob. It is very blobby. So I had the awesome opportunity to meet Deborah, Geek Mom Projects, in real life this past weekend. It was so much fun. It was so much fun nerding out with her. And she had this blob that she had made, and it had these big old googly eyes. And she had sort of bent her wires into this swirly pattern. And I was entranced with it. And she's like, "You want to build one?" And I was like, "Yes." So you know, she gave me like a spool of this. Let's see if we can kind of get a little bit better on it. Oh, I think we can probably zoom in on this pretty well. Yeah. So these are addressable LEDs. And there are 3 wires going to each of them. They're all like daisy chained together. And, you know, they're just like one continuous strand, I think 66 feet, like 200 LEDs. And it just comes wired, you know, with a wire here to a USB plug. And it also comes with a remote. So there are all sorts of like patterns built into it. And I started playing around with mine, and I was like looking at the zip ties, and I was like, "Oh, I wonder if I could like twist this up or whatever, and try to like do it without zip ties." And then it occurred to me that I could knit it. And so you can see here that it's just like, I don't know, it's going to be hard. It's definitely difficult to kind of see when you can't see the depth very well, you know. But
could you like put your hand inside it?
Yeah, I can't really because it's all cinched at the one end. But yeah, it's like, trying to get a background here. There, you can see a little bit how it's basically loops pulled through loops. So I made sort of this flower petal pattern, and then I took the strand and I just pulled a loop through the one petal, and then pulled another loop through the second petal, and then it just kept on going all in around until I was out of strands. And
let's see. That kind of like circular knitting, like the sock knitting type? I don't know that much about knitting, so forgive me.
No, exactly. That's exactly what it is. It's just knitting in the round. And when you knit in the round, you sort of just make this spiral. And with knitting, it's not super apparent that you're kind of like spiraling up because the stitches tend to be kind of short. And so even with here, you can't really tell that it's spiral. It looks more like, you know, complete circles. But yeah, when you just start going, it just sort of, you know, the one row just blends into the other. And yeah, you can just keep going. So yeah, that's what I did. So then like the magic kind of happens when it goes through these patterns, and it's just like super fun. So now you can kind of get a better idea of the circular nature of it. And then
looking.
Yeah. But Deborah's is voice reactive too. And so that is also super cool because, you know, you talk to it and it just like glows and stuff. And it's like, oh my gosh, it's like a little pet.
Do you know what she used to make it voice reactive?
I think it was a microbit.
Oh, cool.
Yeah. I thought that was like a cool and like easy way of doing it.
How advanced is the microbit? I don't know if you didn't know this off the top of your head. How advanced is the microbit's like voice capabilities?
It basically just has a microphone.
Okay, cool.
So it's only reactive and stuff. Hello, Bob. How's it going? Thanks for joining. Good day to you too. But yeah, so it just has like a little microphone and like a little beeper. I don't even think it has a speaker in it, like a true speaker. And it has a light sensor, like magnetometer, like I think it's like a full 9-axis accelerometer gyromagnetometer thing. I think that's mostly it. And the little LED matrix display, buttons, and I think there are some capacitive touch features on it too.
Cool.
Yeah. So I had Deborah give me like the super quick blitz dump of information of like how they worked and stuff like that. And she showed me make code and how easy it was to like get started with that and just, make it do stuff. And that was super, super duper cool. Yeah. Cool. Yes. Bob is stoked that you are here.
Yeah,
I'm stoked too.
Stoked to be here.
Bob, we're showing off the blob that I made with Deborah. So it is very lovely and blobby. But yeah, I do want to hook this one up to like a microbit and make it a little more reactive because that was just super cool. And I need giant googly eyes too.
Yeah, of course.
Hello, Brent, how's it going? Awesome. Thank you for saying hi. It's always nice to know who's like hanging out in the chat. Yeah. So this was like a little fun project that that I did with Deborah. I'm gonna like unplug this so it's not shining. Okay, Blob, putting you down. Blob. Okay, and so the other thing, and I'm gonna do the camera here. Let's see if I can do this without totally. So I wanted to show off. Dun, 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 dun. Careful. I know. Don't zap yourself.
Oh, the blob is knit, Bob, just so that.
Oh,
if you missed it, the explanation.
Yeah, so the blob is it is just knit. There's no yarn or string in it. But the LED strand is knit together. Yeah, so it's the LED strand that I like just knitted with my fingers in order to have it like all stay together. Yeah, let me just do a quick explanation of this. It's interesting. It's definitely aliasing more on camera than it does in real life, right? You don't see that flicker at all in real life. So right now that's time 5:07 whatever. That's date year 2109. Oh, 02. We're up a day.
Slightly in the future.
I know, right? And then it goes to temperature after that. Oh, that is funny that we're a day ahead. It wasn't a day ahead when it was in August. And so yes, that's the temperature in here.
Time's doing weird things. Like I don't blame it. Who knows?
Oh, and then the other cool thing is that it also like you can do different colors at the bottom if you want to. So yeah, that's kind of the underlighting is nice. So yeah, that's our fully functional now Nixie tube thing. So hopefully that will give us like good luck, right? For fixing it.
Yeah. Yeah, hopefully.
Yeah. And then yeah, the other thing, like we showed this a bit, but this is like actually finally working. Let me do that maybe. And so this is like the fully working oscilloscope, and I've now used it a little bit, and yeah, it's pretty cool. You adjust the volt scale over here, and you like cycle through the different other adjustments over here, like trigger and time scale, and it's mostly it, and trigger mode. And yeah, it's kind of cool because I can just have it running here. And if I want to show you something on the oscilloscope, I can easily put it into the camera frame without having like something on the bench that I then have to figure out how to like transition the camera angle to or whatever. And like along these same lines, I remembered the other day that I had this kit from a while back. So maybe I'll try turning this back on again. Maybe the glare won't be too much. Let me do that. So this is a cool waveform generator kit, and it's like a full solder it yourself kit. The oscilloscope was super cheap. It was like $20. This one's a little more expensive. It's like 50 to 60 depending upon where you buy it. But
so
you know,
what is a waveform generator kit? Maybe you give basic explanation for folks who might not know.
Yeah, it generates waves.
Sweet.
Waveform generator generates waves. So you know, it generates a repeating signal, and it could be a sine wave. So a very roundy, smooth wave, or it can be a triangle wave, or it can be a square wave, or it can do pulses, and you can tell it what frequency. You can tell it like what frequency. You can generally do amplitude a little bit. You can offset it so it can be symmetric around ground, or you can like offset it so it's 0 to 5 volts. And you can do stuff with square waves like
that you might want to use a waveform generator in.
So you can use it to create tones and sounds if you want to. And for like square waves, you can use it to generate like PWM pulses. So you could use it to like set an LED to a certain brightness, or set a servo to a certain position, or set a motor speed, set the speed of a motor.
That's kind of cool because I feel like a lot of the frequency and wave stuff that like people who do like basic electronics, they're using it all the time, but it's hidden by like all entry-level code. So people think it's something like totally mysterious, but it's actually something everyone's using all the time.
Yes. Waves are great. And they can also be used to time things as well. So like to supply a clock signal to a processor or to a chip or something like that. Just like a regular chain of pulses with which to compare other trains of pulses against. That can be handy. Yeah. So so Bob says, yeah, waveform generator feeds oscilloscope. Yeah, totally. So I could hook those up and do that. Might do that a little bit later because I wanna see the cool Heathkit Nixie voltmeter. I think that this is super cool. I've never seen one of these before. And tell us all about it.
This I don't have a lot of information. Maybe we can like discover this together. But an acquaintance on Twitter mailed this to me and because I was showing off like my collection of vintage voltmeters that are mostly from flea markets, and I saw this one and I was like, I need this ridiculous beautiful device. So that's like basically all the information I have on it. I will plug it in and show you guys how it is broken.
Yeah.
So yeah, you can kind of see how is my camera? It's like this. Okay. Yeah, you can kind of see this one digit here is on, and it's kind of like all of the numbers are on at the same time. So like the Nixie tube has like these sort of like layers of filaments of numbers that are kind of one on top of each other. And if you kind of like press it in, it sort of glitches a little bit. So, you know, I'm pretty sure there's just something's not in the right socket. So yeah, like I have plugged in some leads at one point just to kind of like see what I could get it to do. And basically it just does this. It doesn't do anything that's not this.
No. Huh.
Yeah.
So no other digits work, you don't think? Or is it just that one digit that you think is out?
I've seen a few other digits flash on and off, but sort of in my time of like kind of poking at it to like, you know, see what's going on, like I think they've only disappeared. So like I don't know. My suspicion is maybe I just need to get in there and kind of reseed everything and it'll be fine. The person who gave it to me said that they tried that. So you know, maybe that's not gonna work, but we'll see. I also have some rubbing alcohol. Maybe I'll clean off some things, or maybe they'll just be something else that is not connected. And who knows? I don't know.
Nice. And so yes, so this voltmeter plugs into a wall in order to operate, and it's going to be unplugged while taken apart.
Yes. Yeah.
Yes, Nixie tubes generally have like 100 volts feeding them, and so always good to take a gander without power to see if hopefully you can see something like easy and obvious wrong with it, maybe.
There is a warning on the back that says just to make sure it's unplugged too. So like everyone's like on the same page here.
Nice. Like it.
Yeah. I was shocked by a Nixie tube circuit one time. I learned my lesson really good. I think it was like very similar to the kit that you have. I was like, a friend had it and I was just really excited about it and picked it up, not really paying very much attention.
Yes. I think I'm probably going to do that one of these days, which is why I'm like, oh man, we really need to get that thing into an enclosure.
Yeah. It's cool, but it's treacherous.
Yes. Oh.
What part do you touch that makes it shock you?
So there's high voltage. There are high voltage lines that feed the actual tubes because the neon basically needs high voltage in order to fluoresce and light up. So the sockets, some of the leads coming down off of the tube itself, those will actually be like 100 volts or so. Yeah. And then it'll also be running on different places on the board because the board is generating that voltage. So, and then like feeding it out to all the tubes. So yeah, it's hard to know, hard to say exactly where it is. Yeah.
But it will get you.
Yeah. Hopefully they didn't put anything high voltage near the edges where people are more likely to grab, but you know, I'm not gonna bet on somebody else's design when I don't have the schematic.
Okay, so
Tommy, how's it going? Thank you for joining.
I'm super happy to see this circuit board. This is like I love like circuit boards for their art form.
We're gonna make that camera big here so that woohoo, nice.
Yeah, and it's got like some really cool like swoopy circuit traces and like all kinds of like really cool stuff going on.
Hand laid out with pieces of tape, probably, or a pen drawn with a pen. Either one.
Do you know how like what insights do you have on this type of circuit board layout? I'm putting you on the spot, but you seem to know something.
Yeah, I know a little bit. Like I've never laid out the board quite like that. I have etched my own boards using etchant and ink as a resist.
Oh, cool.
So and that was a long time ago, but and we actually used one of those like little Shoreline. I think Shoreline is the brand, CNC mills. They were like one of the first like tiny desktop CNC mills, and we like basically put a pen in there. And it was like a specific type of like paint pen. I don't recall exactly the type or formulation, but it was like specifically used as a resist. And so you basically like, we plotted the traces. We had done the board layout in pads, which was like, I think it might have been DOS. I don't know. If it wasn't DOS, it was very, very early Windows. And so, you know, it basically generated a file in this like plotter format, and we put the pen in, and then the pen drew the circuit on the circuit board, like on a piece of double-sided copper. Brent says, beware of still charged capacitors, Lee. And that's a good point if you have any big caps in there. Yeah.
I mean, I don't know what's in here, but I will be aware.
So yeah, and so that's, you also might see sometimes like on old boards that like they might not have a full ground plane. They might have like ground hatches. And
yeah,
so
I can actually see that on here for sure. Like, is that what this is here? Like these?
yeah, it might be. I can't quite see. Can you get it closer? I don't know if it'll focus, but yeah, it looks solid from here, but yeah, the ones that I'm thinking of are even more crosshatched. They're like an obvious mesh instead of a ground layer. And that can be an indication that it's been, done by pen plotter, because of course it's a lot faster to draw like a crosshatch pattern than it is to draw like to completely cover a surface in ink.
Right.
Yeah, and then you put it in etchant, you warm the etchant up, and you etch away the copper.
That's super cool.
Yeah, but there's also this tape method, and I don't really know much about that. I mean, I've heard about it from other people who did that, but there was apparently like a certain type of circuit board tape that you would cut into strips, and I think some of it may have been like also pre-cut at different thicknesses and stuff like that.
That's what I used for the circuit board painting I made you. The tape is from the lines. I used the tape that my dad had from his old like college days stuff.
We're gonna have to maybe like get that in here and take a look at it and show it off.
It's got a bunch of really cool like old circuit board layout type stuff. It's really cool.
Oh, maybe we'll get him on here and have him explain to us what it all is. So yeah, a lot of times those like swoopy things were just like hand laid out tape or hand drawn with ink, and and that's why they look so like kind of cool and organic, because there weren't any rules. The computer wasn't doing it with nice straight lines and 45-degree angles. And yeah. Oh, Brent says tape layout is how he started. Awesome.
That's really cool.
Feel free to tell us more about that. Yeah.
They look so like, I don't know, like you just don't think of computers, like this is my art brain talking, but like you just don't think of computers looking like this.
Yeah.
And that's why every time I open them up, I'm like, oh, like computers are like people too. Like, kind of like, I don't know. This
nice.
screw's being really stubborn here.
So, Bob, you had asked earlier about how high of a frequency does this waveform, does the little waveform generator go? I don't know off the top of my head. I'm kind of playing around with like entering different things into it. It might go up to a megahertz. It says it is on the display. I have not verified that with the oscilloscope yet, but yeah, I'm not sure what it taps out at. Maybe the internet will tell us. The model number of it is FG085. I think I might have gotten this particular kit from SparkFun, but like you can get them a bunch of different places nowadays. I think like Amazon and wherever. I don't know if Adafruit sells one or not. Let's see, G085 manual. So let's see what it says to us. Power switch. Looking for like specifications here. Aha, frequency range. Yeah, it says it goes up to 999.99999 kilohertz, but in spite of that, no limited range is set for frequency entry. In spite of that, it should be aware of that there are practical ranges for output frequency due to the low resolution 8-bit DAC and slow sample rate. So sine wave is up to 200 kilohertz, and then everything else, square, triangle, ramp, and staircase is up to 10 kilohertz. So, not like super speedy or anything, but not bad for something that you can just like stick on a bench and like power off of a battery. If you just need need kind of like a repetitive signal, then there you go.
So I'm trying to figure out what my next move is going to be here. I've got like this front plate off. And these screws are being kind of stubborn at the bottom, but I realized maybe I don't even need to take them off.
Okay, yeah.
Yeah, I don't know. I don't know what my next move should be. Should I try and like reseat these guys or?
All right.
Sure.
So now we can see your tubes, and I see like the spacers around the leads there.
Mm-hmm.
Can you see what they're soldered into? Is that uncovered? Oh, yeah, it's kind of all interesting. How do you, I feel like we need to get that back circuit board off somehow. Is that a screw in or is that
I think
soldered in?
Maybe this will take it off. I was like hesitant to touch these. There's only 2 of them. I'm not sure why they are the way they are, but maybe it's them.
The screws, huh? Ooh. Let me see also. That's right. I just downloaded what appeared to be some sort of manual for that. Let's see if I can find it. Yeah. It's somewhere in my phone. See there.
Still feels like it's pretty well stuck in. Yeah, it's like really strange.
Those knobs don't go, do they go all the way through to that board, or are they on like a separate board that's in front of that backboard? Because maybe the knobs are, maybe the potentiometers are kind of holding that in, and if you pull a knob off, then there might be a nut there. Yeah.
I think you're right.
Haha, Bob's thinking the same. So this is a cool piece of info from Brent. He says that professional PCB layouts would be hand placed at 4 times scale on transparent Mylar film over a light table, and then photographically reduced to 1x for photoresist exposure. So that explains a lot. Then you wouldn't, in order to do really fine pitch things, you wouldn't have to be like dealing with like super tiny pieces of tape.
I feel like I've seen that before with like ruby lith, right? Like that's like the red photoresist. It's also used in craft.
I don't think I've ever seen that or done anything with it.
Oh man, it's super beautiful. And like I got really interested in ruby lith a couple years ago because it's like also a crafting material. I think like the link between totally. That got me somewhere.
Awesome.
A couple of things came out, not sure where they came from, but we'll find it.
Of course, now I should be saying that taking pictures during disassembly is always a good idea.
Well, we got this documentation of the stream. So
right, exactly. We got the live stream documentation.
Counting on you guys. This might be a 2-week situation.
I'm like looking at the banana jack, the banana jacks too, and wondering if they're also like holding that plate on.
I think like after I get this next one off, it will all come apart, but I'm worried for what will happen. Like when I say all come apart, I mean like
really all come apart.
It might all come apart, yeah.
Well, what's the worst that can happen? We'll make it more broken.
Yeah, like it's fine. All right, it's pretty loose in there now. There we go.
Yeah. Awesome.
Oh wow, this thing looks pretty cool.
Nice. Man, look at those pots. Those look cool.
Yeah. They're also very satisfying. Like they're very, very clicky, which is great.
Nice.
Okay. So now the whole thing's a bit sticky, which might be contributing.
Maybe something was like a drink was dumped in it, perhaps.
Possible. Okay, so like just in like visual inspection, it looks fine. This like icy isn't like sitting super well, so I'll like push that guy back in. Yeah,
they're all in holders.
Yeah, they are.
Huh. I mean, it's nice. You can easily replace them.
Yeah, what do you guys think? Like, what would be a good debugging technique here?
Can you see where those are soldered in, like on the bottom, where all the legs for all the leads from the tubes?
Oh yeah, I see this. Like, I'm trying to show you guys. Yeah, I can see this kind of like array of pins at the bottom here.
Oh, interesting. So they're not in a circular pattern; they're more like in a grid. It looks like maybe a little bit.
Yeah, totally. They're definitely in a grid.
I would wonder, like, is there anything obvious that you can see there? Is there any, like, I would look for super obvious things like parts of the board that are burnt or scraped, like if a trace is like cut, things like that first. And you always also, like, you know, if it smells weird, if it smells like burnt electronics, using your nose to kind of like sniff around the board. I have done that before.
It smells really old. Like that's all. It smells very old.
It's got that old multimeter smell.
Yeah. There's a couple of pins that that do look like, I don't know if they're burned, but like definitely like more heated. Like, I don't know if you guys can like see, but there's like a few of them.
Oh yeah.
That are a bit darker.
Yeah. Yeah, definitely.
Like I could go in there and just try and like clean it.
That would be my first thing. If there's nothing that obviously looks like fried, then my first thing would be just to like kind of give it a good cleaning. And maybe, you know, and maybe after that also reflow those leads.
Okay. That's a good idea. I can do that.
Yeah.
Cool.
Of course, I'm sure that is leaded solder that's on there. So
yeah,
you have concerns about contaminating a lead-free setup.
I will be washing my hands. Yeah. Just kind of doing a bit more of an inspection and seeing if I can like find anything else. But like they're like the tubes themselves, like I think the person who gave this to me like spent a fair bit of time like trying to reseat them.
Are they in sockets? Are the tubes in sockets, or are they soldered in directly?
It looks like they're in sockets. I think I've never seen Nixie tube sockets before, so I think so. Like that's what this is here, right?
It looks like it to me. I have limited.
Should I try and pull it?
Yeah, you could. Just lightly wiggle and see. Word to the wise, it can be really hard to get Nixie tubes back in sockets just because they have so many darn little legs.
That makes sense. It doesn't immediately want to come out, so I'm not gonna force it.
Okay. Yeah.
I think probably cleaning is gonna be my first step.
Yeah.
I'm gonna have to be right back though, because I remembered the rubbing alcohol, but not anything to apply it with.
No
So-
problem.
So give me one second.
Yeah. No worries. Yeah, super interesting. So I'm thinking, oh, they could just be, yeah. So Brent says they could be sockets or they could just be spacers. It looked to me like the white things were spacers and the black things might be sockets, but it's hard for me to tell. Definitely hard for me to tell. Yeah. Yeah, I don't know. So I'm thinking, yeah, your point about broken solder joints near large components that can mechanically move, especially when subjected to bumps and shocks. That's a good one. I'm also thinking wires. Wires are always a common source of failure. So just like, and there is a fair bit of wiring in that multimeter. So checking all of them and maybe checking continuity as you wiggle things is a pretty good idea, as well as checking where the power enters, because that's the wire that is going to have gotten the most wear and tear over the years for sure. Those are my thoughts so far. Does anybody else have any other thoughts? I'm curious. I don't know if did you hear all of that, Lee, or were you out of?
No, I was out of earshot. I heard what sounded like the end of a suggestion, but I missed the beginning.
So Brent makes a good point that broken solder joints are common, especially ones that solder in mechanically large components.
Mm-hmm.
Because when they're bumped and subject to shock, then they have more weight and can move more and break more things. My thing was wires. Wires are always sources of problems, and so the wire, the input cable might be a thing to look at. I mean, it's hard to say. Like you got something when it turned on, so obviously some power was getting to it, but checking the integrity of that cable would not be a bad idea, as well as there's a lot of internal wiring in there, and you could beep out those wires, especially while you're wiggling them, to see if anything is the problem.
Yeah, I was kind of just thinking that, like, and on the top, kind of right up here, just where because this platform's kind of wiggly, like there's a whole bunch of wires that like attach to it. And when I had it plugged in, I was like pressing it like this, and that was kind of causing some glitches. So I think that's a pretty good bet. That it's one of those. So I got my multimeter here, so I'm gonna like do a little bit of cleaning, but then maybe I'll just like test a couple of those and see.
But I think like after that kind of like after visual stuff, after continuity checks, then you're kind of in the realm of starting to power it on and poke around carefully.
I'd be so nervous.
Yeah.
I mean, hopefully, maybe we'll get there. Maybe that's what I gotta do, but hopefully like there's just some continuity check I can do, and it'll all come together.
I want
to challenge myself,
always hope for the easy fix, for sure. Check the easy stuff first.
Yeah.
Yup.
I like this clock, but I don't want to get electrocuted for it.
Yeah. Agree. Yeah, and I mean, of course, it could also be, potentially the tube itself. I'm wondering, do you know what kind of tubes those are, and have you done any looking to see about replacements, how readily available those are?
No, that's a great idea. I should find, like while I have this all open, I should make sure to see if I could find some kind of part identifying feature.
Yeah. Definitely take as many pictures as you can of like every component close up, markings, whatever, while it's apart.
Yeah, that's a great idea.
Okay. I'm going to see if I can pull up that manual again. It was an IS-1202.
Let me check.
I think.
It's here. I am 1202. Yeah.
M-1202. 1202 manual.
Oh.
All right, let's see.
Oh, replace fuse with same type and rating. Like a little warning inside.
Yep.
Just feel like electronics these days are never this helpful, you know?
All right. There we go. Ooh, test and calibration. Ooh, interesting. In this section of the manual, you will test and calibrate your IM1202 digital multimeter. If at any time you do not obtain the results indicated, refer to the in case of difficulty section.
Well.
Locate and repair any problem before you continue with the calibration. Well, maybe we should check out the in case of difficulty section on page 45 or 47.
Yeah. Wow, that's
right?
actually really phenomenal.
Let's see. Let's see if I can print this out from my phone because, like, you know, tiny screen and old eyes and all that crap.
I hear you.
Yeah. Come on, wireless printer, work with my phone. Yes.
Is it printing on the phaser?
I think so. Okay. It says it's low on toner though, so I don't know. We've been eking out the last bits of our cartridges. Yay! It's working.
Okay, so now I'm like a little bit like, before I get too in there, like I don't want to zap myself with any capacitors. Anything I can like do about that, or should I just like go for it and hope like?
Well, you can discharge a capacitor by shorting it out, basically.
Okay.
Of course, you could actually, with a voltmeter that works, probe across any capacitors and see if there's voltage across them.
Okay, I could do that.
Yeah.
I can do that. I do have a modern version.
You have a voltmeter to troubleshoot the voltmeter with.
Yeah. It's like, I know what'll help me with this.
Oh, interesting. They actually give like waveforms at certain points in the circuit.
Here's your book.
Ooh, cool. So this is our manual here. Excellent.
Great.
Excellent. Dang. Oh my gosh, there's a schematic. No way. Oh my gosh, there is a schematic. Oh, we might have to print that one bigger.
Wow, okay. Yeah, I think
Holy.
we'll be able to do this. We'll be able to do this for sure.
Wow. Cool. So there's a main circuit board and a logic circuit board. Those seem to be the two sections. Logic circuit board has the ICs on it. Main circuit board.
One of its feet was inside it, so that's a good sign.
Oh, interesting.
Yeah, like one of like the little rubber stops. So I was like taking it apart. I was like, I wonder where that got to. It's just wedged in there.
Huh. Was it like touching any components? Like, did it shove into anything, perhaps?
It was like kind of in here next to the pot. So I don't know. And it's like, well, maybe it was dislodging something. That's possible.
Ooh, yeah, there you go. Check that out.
Maybe I'll do.
How was it held at 90 degrees to that other board? Was there like any kind of connector or just screws or?
You know, I think it was just in there, and because this weird foot was kind of wedged in there too. Like I can kind of put it back and it sticks. But
Huh.
I think I don't know, I was being very delicate with it, you know.
Yeah.
Yeah, now I'm starting to feel like maybe it's something that's connecting the top to the rest that's like just like needs to be reflowed.
Mm-hmm.
I feel like that would make sense. And like these two, there's 4 wires that are coming in there, so I'm gonna test them.
Mm-hmm. Yeah, definitely. How many? Let's see. How many tubes are there on that? How many?
So there's 2 like full like number tubes, and then there's like 2 of these which are like lines, and I guess, and then these are I think decimals.
Got it. Ooh, yeah. So there's like a it looks like the one is maybe just a 1 digit.
Yeah, like I think that makes sense with like this like piece that went over it. I think the 2 dots are indicating like the positive or the negative.
Yeah, so it looks from the drawing, it looks like there's something that says over and plus and minus on the way left.
Oh, and yeah, and then this is a 1.
And then a 1 digit, yeah, and then maybe a decimal point, and then the 2 full tubes.
Yeah. Where is that decimal point?
It looks like it's like between the line, the 1 and the first full tube. It's from the drawing. Yeah, like there.
It doesn't look like it's there.
I wonder if it's part of it. It's actually drawn like within the tube here. I wonder if that's accurate or not.
Oh, if it's like inside the bottom, like
inside the other tube, like the full tube, yeah.
Oh yeah, no, I do see it. Like you can kind of see in the corner.
That's cool. 2.5 digits, yeah.
It's funny. This is like they're always so clever, you know, like these like really older solutions. I'm always it's not how I would have expected it to be going together.
Yeah, so let's see. Cabinet, front panel. Oh, hey, there's like a whole drawing here of the 5 screws that you take off to pull it apart.
Wish I had that before.
It is funny though, they don't actually tell you about the knobs, which I would have expected. Right, so let's see. Yeah, like DC voltage measurements. So yes, so that is so interesting. Okay, so the range, right, is indicative of the digits as well. So it's basically a range. I don't know what you would call this, but like the range is 2, 20, and 200. So so you'll be able to see up to 1.99, right? And that's why they don't need any other digits there, because then you click up to the next range setting And then that's what the overlight should tell you, right? So yeah, that's how they've done that. That's funny.
Clever.
Yeah. You just get one digit, 1. No more, no less. Cool. So yeah, they have there's this whole section on waveforms and like, test point D16 anode and what your oscilloscope setting should be on and what the waveform should look like.
Oh, wow. Okay.
Yeah. Possible cause of improper waveform, the diode or no voltage from transformer. And they go down with, I guess there are only 6 things.
Well, I sure hope it's one of those.
Right? But that's pretty interesting. That's pretty cool that there's like so much detailed information on troubleshooting. Waveforms as displayed on Tektronix model 547 with type 1A4 4-channel amplifier line sync. So find yourself one of those.
Yeah, all you need is the perfect setup, and the answer is so clear.
I love how everything is like properly documented and qualified. That's great. Let's see. So
it's definitely looking less gross under here now. Like it's,
nice.
Like that's good.
And like, smell any better?
It does not. I feel like these electronics, like there is no amount of cleaning in the world that will restore them.
Oh God, what is it? There's this plastic that used to be used on the handles of tools, on like tool grips, like screwdrivers and nut drivers and stuff like that. I forget what it's called, but as it ages, it off-gasses, and the off-gas smells like puke. Like seriously smells like vomit. And you get like these, there's a particular type of old Excelite nut driver. And it's a real shame because the nut driver set is so great. They're like the perfect, like small, stubby, but compact size so that you can like get a fair bit of torque on things, but they're short. So you can like get them in different places. But oh my God, the smell is just awful. And like no amount of cleaning gets rid of it because it's off-gassing.
Right. So you're just like totally stuck with it.
Yeah. So I guess like maybe you could dip it in like lacquer or something like that. Maybe try to contain it all. But yeah, it's funny. Is there a year of publication on this manual? Let us find out. Copyright 1972.
Dang.
It's older than I am. Yes. Only by 5 years. Yes, Brent has the vomit nut driver set. Yes. Right? And they're also really pretty. They like come in this beautiful array of rainbow handles. It's like, it's quite a nice set that I want to love and could not. I think I gave it to your dad, Robin. He really likes that smell. I'm like, it's like nostalgia for him. I'm like, oh God, you can have it.
It's not Bakelite, is it?
No, it's not Bakelite. It's something else. I looked it up when I was trying to figure out what to do about that. But yeah, Brent keeps the lid on it. Yeah. but still, you have to take it out to use them. And it's like, ugh. And then they also like the full set also had a handle with like a hex like slot in it so that you could drop the nut drivers with that all had these small like spelter handles into the larger handle in case you needed to get extra torque on something. So it was like really a nice set. Except for that small problem of it smelling like puke all the time.
I definitely feel like plastic has gone through some like weird design phases as a material. There have been some bad plastics.
Right. Ooh, okay. I have gotten to the in case of difficulty section.
Okay.
Manual.
So is there a picture for what to do if it looks like this and still isn't working?
Let's see. Ooh, how about this? Readout tubes light but are dim and all 10 digits come on.
All the digits came on.
Like one of the digits was, but all 10 digits on one of them came on, right?
Yeah. That's totally what was happening.
Was it dim?
Yeah.
No. So, possible cause. 1. Connector wire A on logic circuit board not making good contact with connector pin A on main circuit board.
Oh my god, this is so exciting. Okay, which one is that?
So that is one. There is also same thing, but with connector wire B on logic board, not making good contact with connector pin B on main circuit board. And then there's the catch-all. And there's transistor Q11 and its associated resistors, capacitors, and diodes.
Or it's broken.
Or it's like all this other stuff.
Okay. So which one is which pin is that talking about?
Okay, so let me see if I have the schematic, but let me see if there's like a diagram at all of like, actual like assembly diagram showing the position. Let's see. God, it's wonderful what you can dig up on the internet these days.
Right? Honestly, I would not have expected the answer to just be in the manual. Maybe that's very millennial of me, but
whoa, there's circuit board X-ray views. No way, these are cool. I love it. They have each layer,
Oh wow.
I think it is only a 2-layer. It's funny that they called it X-ray views. So there's main circuit board viewed from foil side, main circuit board viewed from component side. Okay, so might be able to figure out where these connectors are. Connector wire A on logic circuit board, not making good contact with connector pin A on main circuit board. So I'm trying to figure out what connector pins we're talking about. I'm not seeing things that are an obvious connector. Are they using connector in a different sense that I'm?
Do they mean the these things
I don't think so, because they're talking about the connection between the two circuit boards. So the logic circuit board is the smaller one with the tubes and the ICs on it. Yeah, that's that one.
Okay.
The main circuit board is the big one that's in back. That's at the right angle.
So there's very few things coming off that actual board. There's 2, and I checked those 2 connections. So there's these 2 that go to this potentiometer, and it looks like they go into this IC here. And those are the only 2 cables. Then there's these 2 other power cables that are going into I think they go into the plus and minus indicators.
Mm-hmm.
So if we're thinking like wire and like,
Yeah.
could that be it? Like, do these maybe just need to be like reflowed? Like these.
I would try that first. Are you able to beep them out and wiggle wire at the same time?
Okay, let's see. If I have enough hands.
Yeah, sounds good.
Yeah, that seems fine.
Yeah.
Let me try the other one.
Yeah.
Maybe there are a couple. No, there aren't.
I'm curious. Okay.
That seems fine too. Like kind of wiggling it. It doesn't seem that upset.
So now it also talks about transistor Q11 and its associated resistors, capacitors, and diodes.
Yeah, those are the only two things connecting these.
Ooh, so this is another interesting one that could perhaps describe the problem.
Mm-hmm.
A particular digit lights. However, all numerals appear dimly lit. For example, a 3 condition always faintly lights 0 through 9. And the causes of that are an open tube socket pin or an open decoder driver pin.
Okay. What do they mean by open?
Unconnected. So you mentioned that one of the ICs wasn't seated very well when you first opened it up.
Yeah, it was this one here. It actually keeps popping out, kind of.
Oh. I'm wondering if that could potentially...
I know this isn't the case for electronics usually, but like it is the IC that's furthest away from the Nixie tubes, just for like, reference. I'm not saying it's not related, but it is the furthest one.
Yeah.
I know that's like terrible logic. But imagine if that was it.
Yeah.
Yeah, I'm gonna press all the others in to just like see, but they're not budging. Like
and I mean, an open connection could also be caused by corrosion. So tubes and sockets are sort of like, well, sockets and pins are kind of notorious for not having great longevity, right? Because you get humidity, you get like a little bit of corrosion started, and eventually that just covers the pin, even though the pin hasn't really moved. And it makes it so that it like looks fully seated in the socket, but it's not actually making electrical connection.
I think I figured it out.
Oh, I
totally figured it out. Okay, so I mean, like, totally maybe. In here, there's like these little connectors, and I thought, I don't know what I thought, but they are labeled A, B, C, D, and they do kind of like this. That's actually what's holding the board, like holding the board A to board B.
Okay.
So I think that they need to be like cleaned, or maybe it wasn't like fully plugged in. Or something like that. Like that, I think makes sense. I thought that it was just kind of wedged in here before, but I think they like these
that there actually is something making electrical contact as well as mechanical like support.
Yeah. And that would also explain why when I was moving it, it wasn't. Yeah, actually, I'm pretty sure that's it, because when I'm pressing it back together, I can kind of see that connector B is like, it's like sitting like on top of the connector instead of like going inside the socket.
Oh, so connector wire B might not be making good contact with connector pin B.
Yeah, that is my suspicion.
We have somebody saying in the chat, hello, Henry. He says, hey, look, it's me, the guy who used to own this thing.
Yeah, hey, we're fixing it.
Hey, Henry, how's it going? We found the manual. We're RTFMing.
Well, this is
Interesting.
exciting.
So are you able to like bend stuff back into place so that it makes good connection?
I'm gonna try and put this in here, and then I'm gonna check the continuity and see if it is working.
I would also say, like, if you can get it to a stable position on your workbench.
If I can, yes.
Yeah, like plugging it in like there and just seeing if there are any changes, would be good, so that you don't have to keep on like taking it apart all the time.
Yeah. I'm thinking about that. I'm like a little bit nervous about it. But also in trying to reseat this, I like am increasingly like I'm definitely like overselling this, but like I'm increasingly convinced it's the problem because the connection is so unstable.
Yeah. So Henry says the only thing he did to try and fix it previously was reseating the tubes. And it did work for a while, but it also could be the other board connector that he wiggled during the process, and that hopefully we found it.
Yeah. I think that this all checks out.
Yeah. Cool.
Let's see.
Well, Henry, I have to say, like this manual that we found is kind of amazing for it. There's very detailed troubleshooting sections and a schematic and waveforms displayed with the test points noted. So like, it's if there's something deeper wrong with it, it is probably beyond the scope of a single live stream, but there are at least resources for trying to understand what that is and actually troubleshooting it. So that's pretty cool.
Okay, so I am now convinced that is the problem. Connector wire B was not seated properly.
All right.
I'm wondering what I can do about that. Like every time I just put it in, like it's just slipping out right away. And they're like these weird, I don't know how to describe it, and you almost certainly can't see it. But they're like these weird little sleeves, kind of like just like there's no like plastic packaging around it.
Can you take the board completely out and like clip wires to it to connect the two?
Yeah, that is a great idea. Cool. Good thing I have a million alligator clips.
Wherever could you get some of those?
Yeah, if only I had 15,000 alligator clips handy.
For anybody watching who doesn't know, we had manufactured these amazing custom colored alligator clips that are these lovely, like I would call them like these tropical colors. So there's like orange and fuchsia and turquoise and like a violet. And so if your alligator clip collection needs like a little extra something, you should look on their website and buy yourself a cool pair or a cool set of super fun colored alligator clips. What's your website again, please?
My website is leecyb.org.
There we go.
Lee Cyborg with a .org at the end.
I love it. I keep on trying to figure out if there's some way that I can like shorten Alpenglow like that, and I have not been able to find anything. I think I
feel like with the new top level domains, like there's got to be something.
Right? What country is OW? Alpenglow.ow.
These are not sticking on the back here.
I did try to buy the domain name Just Alpenglow. I managed to contact the owners, but they sadly were not interested in selling it.
Oh, bummer.
I know. They were very nice though. I don't know if there wasn't an active website there when I tried. It was a few years ago. I don't know if there's one there now.
Okay, so I think for tonight, I'm gonna call this where it's at. And what I'm gonna do, like before I put it back together, maybe next time we have a stream, is I'm gonna get some like thin wires and just like actually just make new connections.
Yeah.
Instead of these, and then I'm pretty confident it will fit. But I have kind of terrible eyes, and I need to get really close up in this thing to do it. So I'm not gonna I'll spare you guys. I'll spare you guys on the stream.
It is hard to do things live.
Yeah. But I mean, this was great because I feel like I am like convinced that is the problem. It makes a lot of sense. And I'm like totally blown away that it's just written in the manual.
Right? It's kind of like me too. I'm blown away that we could actually find this manual from that, and that it wasn't even hard. Like it was on the first page of Google results for like the part number and manual. Like there you go. Okay, download, click. So yeah, that's super cool. Yay.
Yeah.
I'm happy. Not just documented, but the board has labeling. Yeah, exactly.
Yeah, like it's
exactly.
Kind of
I'll send you the link for it too. Just, I mean, I just said how easy it was to Google it, but it's always nice to have a link sent to you too.
It's funny too because like I feel like I'm just used to looking at silk screens on PCBs like they're going to be like white on this like high contrast green, and like it didn't even really occur to me they're kind of like it's red on this like faded teal color. So I didn't even like think to I didn't even think I was looking at the silk screen. I was like, oh crap, it does say pin A and pin B. Like that makes a lot more sense than what I was looking at before.
Nice. That's awesome. That's awesome. Well, I'm glad. I'll be excited whenever it is that this thing is restored to all of its glory. It'll be fun to see. Yeah. But the other thing that's cool is that like if you do that and the digits work again, you can go through this manual. Like there's this whole like test everything out process. And so you could go through all of that and make sure that everything works and like then button it up. And you can also like, we should be able to clearly identify what are the high voltage areas of the board as well, because we have the schematic and because we have the documentation on the different parts and the silk screen and things like that. So that makes it a little less nerve-wracking to be poking around in there while it's actually powered. Yeah. I was a little bit nervous. I did test the capacitors. I didn't see any like residual charge on them, but like I don't know. I'm like 40% confident in my abilities, so like I wasn't like not ready to like really get in there. It doesn't look like there are any capacitors that are like super giant either. Like it doesn't look like there are any like even 1,000 microfarad caps in there or anything that might retain its charge for a while. So yeah, I'm just like not so keen on like getting shocked on like a live stream. I'm like, I know. My favorite thing. The whole internet to enjoy in perpetuity. Yay. Yeah, Bob. It's a Heath kit. It's a Heath kit IM 1202. So that's what it is. And let's see if I can hold up the. Yeah, that's kind of what it is supposed to look like. This is what it looks like now. It has this little like face on it, like yeah,
it's so cute.
That's awesome. Yeah, I mean, maybe in like a future stream, I'll like once this is all set up, I'll like put it
we can poke around on the oscilloscope and like see everything.
Yeah.
When we get there.
Yeah. No rush. Sometimes these things take a while. Parts, just like do it in stages.
Yeah. Totally.
Cool. Bob says that those kits were designed for DIY builders and repairers. So that's probably
okay.
Yeah, probably a
That's
reason
why there's such good documentation. Like, so we see you probably broke it or took it apart.
Oh man, Robert says his first bad shock was messing around with a Nixie tube, and he was home alone and wound up on the floor.
Oh no! See, that's what I don't want to happen to me on live stream.
Right?
You guys will just like watch my cat come and try and just like resuscitate me.
Try to leave you awake. Hello. Oh, all Heathkit stuff was kits and still is.
Oh.
So you think this was originally a kit that like somebody soldered together in order to make the whole thing? Yeah, well, actually, yeah, that makes sense since oh look, on the cover art there's this joyous father-son moment.
Yes.
You couldn't possibly be interested in electronics.
Okay,
they look so happy.
Then it's just to blame like whoever Henry got this kit from.
Right.
You know, it could have been the person responsible for these woes.
Right. Right. Oh man. That's funny. So yeah, like there we go. That's cool.
Yeah.
Cool. All right. Robert said that his dad built a bunch. It's a cat to mom, cat to person resuscitation. Yes.
That's what you guys are here for. You don't care about the electronics.
Yeah. We just want to see the cat trying to bring you back to life. Yeah. Maybe if I bite their finger.
Yeah. Tune in next week, guys.
Yeah. Awesome. All right. Well,
yeah.
I think I call that a success. That's good.
I think so. I think it's a huge success. Like I feel good about the diagnosis. And I think like with another session we can like get it going and like see it in its full glory.
Yeah. Oh man, Brent says at one time you could buy a Heathkit color TV.
What?
That is super cool. Like, I would love to build a color TV.
Oh man,
we need one.
Yeah. Okay, I'm definitely gonna like see about tracking down this kit. That would be like an absolute hoot to build.
Mm-hmm. Totally. Awesome. Well, cool. Thanks so much for coming on and bringing your super cool like kit, and that was fun.
Yeah, that was awesome. It was great to hang out and chat. Thanks everyone for coming out too.
Yes. Thank you, everybody. I don't know what we're gonna do next week yet. I'll figure it out. I have a bunch of kits and stuff, and I actually, so I don't know. I probably won't have parts for this before next week, but I had so much fun just like making that silly little LED blob that I was thinking of having Geek Mom projects on at some point in time, having Deborah on and making some blobs and showing people how to knit their LED strands together. And yeah, that
would be awesome.
That would be cool. And I could probably even sort of like get some links to supplies going ahead of time so that maybe we could do like a little week or 2 week before thing, like, hey, if you want to join us on this, like get these things, and then we'll
I did some circular knitting with, what did you call it, like I don't know, circular knitting with the LED strips before, and it's like really fun and super accessible if people have never knit. So
yeah, definitely. Yes. Bob says Geek Mom projects rules. She does all. Yeah,
totally.
It was so good. I don't know if you were on yet, but I was saying that I think you've seen on Twitter that like I got to actually meet her and hang out this weekend. It was so much fun. So cool. Yes, and this session was lucky 13. Whoop, whoop.
Yep. That's why we solved the problem, because
That's
lucky
right.
13.
That's right. Excellent. Cool. Awesome. All right. Well, we're going to hit it, but see you all
All right.
next week, and thank
See
you for
ya.
coming.